Hello everyone, this is class 17 lab again, class 3. We're doing frequency selective filter here. First of all, we have to set our supply from the signal generator or function generator, 5 volt peak to peak, 0 volts offset and 10 hertz. So let's do this over here. So sine waves, right? And amplitude is 5 volts peak to peak. Frequency I'm gonna do 10 hertz, right? Then offset should be 0 right there. So all good, all good. That's good here. Is on, and over here, this 22K is right here, and also in the circuit is right here, and 10 nanofarad right here is circuit is right here. So our input is coming from the signal generator. We're measuring the input coming from the signal generator. Output we're measuring across the capacitor. Okay. So to the measurement, let's do the auto scale here right now. Let's adjust this. And adjust this too. Okay, so now I bring it down a little bit. So if you look at here, I'm measuring peak to peak for both channel. Peak to peak for channel 1, channel 2 is the same because it's on a 10 hertz. So I'm gonna go into 100 hertz and see what happens. So I'm gonna come over here, put 100 hertz, all right, and do auto scale here. You can see that for 100 hertz, your input signal did not change, but output signal basically went down a little bit, right? Can you see that here, peak to peak? So, so now went down a little bit, right? Then I'm gonna do 500 hertz over here, and also do the auto scale over here. So now look at here, your input signal did not change, it's still 5 volts, right? And your output signal went down to 4 volts now. You can see that. So now I'm gonna do 1000 hertz over here, and if I do that and I'm going to hit the auto scale here, then you can see that now your input signal is still 5 volts peak to peak, output signal was 2.851 volts, so output signal is decreasing quickly, right? Now I'm going to go 5000 kilohertz right here, 5 kilohertz. Then if I do auto scale here again, now look at that, my output signal went down to 724 millivolts, that means 0.7 volts. Input signal is still at the 5 volts, right? So I'm going to go 10 kilohertz now. Then if I do auto scale over here, you can see that now my output signal went down to 0.3 volts, right? So that's what happening with higher frequency, going higher frequency, your output signal is going down and down. That means your capacitor at the output is basically selective about frequency. High frequency is going to give you almost no output. In the lower frequency, you have all the output from the inputs. It's called. Can you if you can do this over here? So you have the signal magnitude over here. This is the magnitude. For us, is voltage, and this is the frequency over here. So at the low frequency, frequency increasing in the low frequency, your magnitude is output. I'm talking about the output voltage. We out T over here. Output voltage over here, magnitude. The low frequency is magnitude is higher and it's going down, and almost zero at the higher frequency, right? So that's what's happening over here. At low frequency, you have the higher output voltage. At the high frequency, your output is going down. This is called basically a low pass filter because you're allowing low frequency to go, low frequency signal to go through the circuit and blocking the high frequency, right? So it's a low frequency signal, low frequency filter. All right, that's all for this lab. And again, you should get the data from your partner. So over here, all those data table, your partner should have all of them, and you'll get the data from your partner, and you can do the analysis. Thank you very much, and that's all for the task 3, the last task of the class 17 lab.